So we go to Code Sculptor, as we did last time. All right, and I do have a piece of code that works, and I will actually put it here. I think I showed it to you last time. I think it was this. All right, because I'm gonna need some APIs, right? So I'm gonna start with presenting a few sources of data, right? So I'm gonna take this please access the same, because you're going to need to copy and paste as well, right? But I mean, the fact that we have the working code, we still want to develop the code from scratch because we want to understand how things work. So this is my GitHub account. Let's go there step by step. All right, and you normally should go here to repositories. You would get one that is Coursera assignments. There's another one which is interactive Python, and then there's a folder called Asteroids. Yes, and this file asteroids.python. Yeah, everybody managed to get there? So again, starting from the right, github.com/Razvan Voicu. We go to repositories. Yes, Coursera assignments, interactive Python, asteroids. And asteroids.python, okay? So as you look inside here, you're gonna see these URLs, and I'm gonna open them one by one so we can see what they are. So just copy and paste. So this is sort of the background against some background for the game, right? And just looks like debris. All right, the next one is nebula. All right, this is the background. The debris is probably what we want to use for the explosion, but this is going to be the background. All right, the splash image, which we would have at the beginning of the game, right? Every game has to have a splash screen, right? And this course was developed by Rice University, so that's why you see the Rice rocks. Maybe we won't, maybe we'll skip the image for the time. And then we have a ship info, right, which we used last time. I think, did we use? No, we didn't. We used a ball last time, right? So you see the image of a ship. So it's two images, the image of a ship and the image of a ship that has thrust, right, whose engines are producing thrust. So next one, so this is going to be the missile, right, that the ship sends to to destroy an asteroid. All right, this is the image of an asteroid. And what else is there? The image of an explosion. We'll probably not reach there today. Right? So you see a sequence of images, which if we would play very quickly, one on top of the other, would get the image of with the feeling of an explosion, right? So if I just play the game, from here, right, as I should, you look at the explosion, right? Okay, shut up. I don't know how to make it shut up unless I close. But, right, you notice that if I divide this long image into squares, right, and I take all the squares and superimpose them, I'm going to get the image of an explosion, the movie of an explosion, right? What else is there? That was the last one, right? We have a soundtrack. I'm not sure whether you have heard it, right? So we have several soundtracks, right? We're gonna not worry about these initially. All right, so what I would like to do is start with a ship that sits in our window, all right, and is able to move exactly like the ship of the game is moving, and right, has this animation of thrust, the appearance of thrust, right? So remember how we operate here. So we have to create a frame. We add stuff to the frame, all right, and the frame starts. And actually, in adding, I'm just going to remove the button. But we want a drawing handler, which is draw, right? And this drawing handler can draw a variety of things. We're not going to be very interested in all this stuff, right? What we want is to draw a ship. So I'm going to copy the code generally because it has this very long URLs, right? So I want to take the ship image and info. So you can do the same. I'm going to explain what these mean. All right. So I'm going to import them, add them here. Okay. And you notice that we have this image info structure here. This is going to be useful a bit later, and I'm actually wondering whether I should bother, because this image info tells us what? That if I go back to the ship image, ship, double ship, right? So we have two ships here. Essentially, each image is 45 by 45. Each image, is 90 by 90. All right. So you see this here. And the center of the image is therefore at 45. Okay, I can't quite remember what the 35 is there. Oh, 35 is the radius. All right, and we're going to need later another piece of information which says how close does the ship need to be to an asteroid to consider it a collision, right? So even though the ship is not a circle, we're going to consider it a circle because it's easier. and we're going to consider it a circle of radius 35. All right, so we have imported this ship image, and for the time being, let's just draw this. And I can't remember what is the command for drawing, and therefore I'm going to find it. Command F, and I'm going to be looking for the ship image. And all right, so we're going to have a ship, and when we draw, we're going to have canvas draw image, right? So this is the command. We can write here and ship image. What else is there? We have to have some coordinates. So we have the image. We want the center, the size. All right. So let's go to the help and find out what draw image is doing. Canvas draw image. All right, so we want image center source with height source, center destination with height destination, right? So what happens now is the following. The image here has a certain size. Now, very typically, we don't want to display in our game the image at the same size. Sometimes we want it small, we want it scaled, right? So we want to say in the image that we are drawing, where's the center, right? And what is the width and height of the image in that, right? And we're going to take advantage of that because we actually have two images inside one. We have two photos or two sprites inside one, right? It's two of them. So I want to select and show only the left side sometimes, and I want to show and select only the right side sometimes, right? When the ship is moving, I want to use this image. When the ship is not moving, I want to use this one, right? So we have to use the ship image. We have to use the center. So again, the center inside the source. So the center is going to be at 45, 45, right? The left image, which is also what we have here, right? So 45, 45. So we're going to use a pair for the center. Then we want to say what is the size, width and height of the source. So the width and height is 90 and 90. So if we look here, right, I'm telling you that this image, I wish I could see borders, but this image is 90 by 180. Okay? I think I can enlarge it. But it's 90 pixels vertically, 180 horizontally, right? But it contains two parts. And I want only the left part, 90 by 90. So I'm going to say that I'm selecting 90 and 90 here. All right. And what else do I need to say? Center in the destination. Okay. So we are having, I'm going to make this slightly larger. We are having a window of size 800 by 600. So I'm going to put it at 400, 400. And what else do I need to provide there? Width and height at the destination. And for the time being, we have no reason to scale. So we're going to say again 45, 45. And here we could say an angle, but if we don't provide it, the angle would be 0. So let's see what we have for the time being. And I was saying that I don't want this just now, so let's not use it, right? So you see that we have the window. Did I say 400, 400? I should have said 400, 300. And we see the ship, and the orientation is to the right, which is 0 degrees. Okay, so let's correct this, make it 300, and then let's add an angle. Let's add an angle of 45. I can't remember whether this angle is. I think this angle has to be in radians. So I'm going to import math. So I'm going to just say from math import everything. All right, and here I'm going to say pi divided by 4. Okay, and you can see that positive angles are downwards. If I say minus pi divided by 4, negative angles are upwards. Can I? Okay, it works. Right, I can scale. Okay. So let's try to add events, and dependent on our key presses, we want to make the sprite move on the screen. Everybody has been able to do this so far?
Getting a couple error in the canvas.draw image.
Yeah, you probably forgot the comma here. So, how do we read the keyboard? And the key handlers are here, right? So we're going to write a function, and that function will receive a code, right? And then we check whether the code is equal to a value that is predefined, right? So this simple GUI has a dictionary called keymap, and then we have a code for every key name, right? So left will be arrow to the left, right will be arrow to the right, right? And we would have two different event handlers, one for the key being pressed and one for the key being released. All right. So let's see where do we add that. Okay. Let's see where do we add that. So I'm just going to look for a key down. Control F. Key down. All right. So this is how we set it, right? So the frame that we have created has a method called setKeyDown, and we're going to add this function. It similar has a handler for key up, and we're going to add this. So we're going to say here before frame start, right? So at a point where we're adding a drawing handler, frame.set key down handler, right? And we're going to call this key down. All right, and frame dot set key up. And because we are using now these names, we have to also create the functions, right? So we have to say def and we're going to receive a key, right? This method automatically fills in this argument. When we press a key, it invokes this method, this procedure, and it automatically passes in the key, the code for the key that was pressed. I'm going to pass first key up, pass. All right, so the code still works. All right, let's add rotation first. Let's add rotation. So we want to get the codes for left and right and use that for rotation. So I'm going to steal the codes again from here. So as long as we are pressing, well, let's not cut and paste too much, right? So if key equals simple GUI dot, and the name is key map, and we have the name of the dictionary is key map, and we have names like left, right? And then we're going to do something. Let's just not do much now. Else, elif, right? So that means else followed immediately by an if equals simple GUI dot key map, right? And we're going to do something else. All right, else we don't do anything, right? So actually we don't need an else here. We can just leave it the way it is. Very similarly, we're going to adopt the same strategy for key up. Okay, so the first thing will be to have a ship angle. So we're going to have a global variable called ship angle, and we're going to have a value of 0 here. All right, and we're going to initialize this with ship angle. All right, so all works fine still, right? You notice that the ship is oriented towards the right, which is an angle of 0, right? And when we have the key down left, so left is counterclockwise, and we should have negative, it was negative, if I remember correctly, negative angles, right? So we should decrease the angle. So we could say ship angle minus equals, and let's pick an increment or decrement for the angle, right? So something like pi divided by 6 could be, yeah, which is about 15 degrees. Might be a bit too fast. Actually, yeah, might be a bit too fast. So let's say 12. All right. And actually, we should use a variable called angle increment equals pi divided by 12, and we should say minus equal pi angle increment right. Otherwise, if the key is right, we should say ship angle plus equals angle. All right. So let's see what happens now. So if I press right, oops, invalid type. Object has no attribute key map. Really? Oh, key underscore map. Sorry, I misspelled. Okay, let's try again. And because this ship angle is modified inside a function, but it comes from outside of the function, we should say global simple ship angle. All right, we add that here. We've seen this before. So as long as every time I press, right, I will see the ship moving at a certain increment. All right, but what I really want is, as long as I keep the button pressed, I want the ship to rotate, right? So how do we do that? And who calls that? So instead of just incrementing, changing the angle, I want to change the state, right? The state is either not rotating or rotating. Okay, so I'm going to have another variable saying ship rotating. Right? So if the value is 0, the ship should not be rotating. If the value is 1, the ship should be rotating in the positive direction, and otherwise the ship should be rotating in the negative direction. Okay? So instead of making the ship angle incremented, what I'm going to do is, so ship rotating here, right? I'm going to say ship rotating equals -1. Equals 1, right? So now what happens where do I do this? Remember this draw function, when does it, this draw function, when does it get called? How does it get invoked? Who invokes that? The browser invokes that, presumably 30 times a second, right? So this draw gets called 30 times a second. It doesn't matter that, right? If I run it, yeah, it's the same image, but it's being drawn 30 times a second. If I change the elements of draw, then I'm going to have the perception of animation, because draw will draw something different every time, right? So this modification, this change, should be done inside draw instead of doing it in key down. So I can say here ship angle, right? And because we have sine, I can say ship rotating times angle increment, right? Is this clear? So I'm setting this to either -1 or 1, And then we're going to, this operation was going to start changing the angle. So I don't need this, and I don't need this anymore. Okay? Is clear? All right. So we're going to need the global here. Ship angle. All right. And I don't need the global ship angle here. I only need ship rotate. So let's see what happens now. So if I start pressing right, if I press right, you see it rotating to the right. If I press left, it starts pressing to the left. But it doesn't matter what I keep pressing or not, right? It just keeps rotating. I can't stop it anymore. I can just change the direction, but I can't stop it. How do I stop it? But I have a key down function here. I have a key up function here, right? What I would like is when I lift my finger to stop rotating, right? How do I do that? So when I lift my finger, I just say ship rotating equals 0, right? And then I don't need two branches of if. All right. So if the key that is coming up is not being pressed anymore, this gets invoked when a key is no longer pressed anymore, right? If the key that is no longer pressed is either left or right, I have to stop rotating. Okay? So now if I run, as long as I press, oops, didn't seem to have worked. Key equals simple GUI left. And there's a global here. Ship rotating. All right. If we don't say global, then this ship rotating becomes a local variable inside the procedure, and it is not linked to this one. So the program works, but we don't actually change the ship rotating that is global, right? Which will not change whatever is in here. Okay? So now I press and it's rotating, I release and it's no longer rotating. I press and it's rotating to the opposite direction. So this becomes a bit difficult to control. So probably we want to go at an even smaller increment. So I'm going to say 15 here. And let's see whether actually we can go even slower. So let's say 30. So this is probably better. Okay, is it working for everybody? How is it different from my phone? It's not different at all. I mean, it's the only thing I can think of. There's another thing. You're opening in the same. You're opening in the same browser. Can you have it open in a separate window the way I do? Because I remember there were issues with that. So you see, for me, it opens in a separate window. Does anybody else have problems? Is everybody else able to run? So, from what I remember, you see, for me, it opens in a separate window. And I remember vaguely that there were problems with a setting where your browser opens new windows as tabs.
Are you on full screen mode?
No, but even in full screen mode, it would still.
No, because for me, like, when I was in full screen mode, it would open the tab. When I was in not full screen mode, it opened the window.
I see. Okay, we can verify then. So I can go in full screen mode.
I went out of full screen mode and now it works.
Okay, yeah. So, yeah. Yeah, it's not a perfect framework. Sorry about that. Cool. So we can rotate right, left, and right. Let's see how we add thrust and we make it move forward or backward, right? So we're going to have a position, ship position. Which we're going to start at the place where we started already, which is 400 and 300, right? And we're going to use here ship position. All right? So what we want to do in a similar fashion, all right, what we want to do is make the ship advance as long as we press, and stop advancing when we release the key, right? So we have a ship position, which is initially 400, 300, right in the middle of the screen. Okay? And again, we're going to have a state, advancing or at rest, right? And here we don't have direction because we can't reverse. It's only forward or stop. All right? So we're going to have a variable called advancing, and we're going to make it false initially, and we're going to make it true whenever we need to make it advance, right? So when key down elif key equals simple GUI dot key map, and this should be up, right? Then we say advancing, maybe advance, not advancing. Advancing is, it's a state, but equals true. I think true is capitalized in Python, right? Yes. And so is false. And obviously we have to make this global. All right. And similarly, in the key up, then we're going to say advance, assign false. And again, advance has to be global. So what do we do in draw? What's going to be the new position? Well, we have an angle increment, right? One thing we should pick is a velocity, right? So ship velocity equals, and we want to make it in sort of pixels per draw. How many pixels in one draw? So I'm going to start at about 5. I'm not sure whether that's going to be a lot or too fast or too slow, and we're going to adjust later. All right. And in the draw, we should compute the new position, right? So the ship position here should be global. So what's the new position?
Ship angle.
So it's the old position, ship 0, right? So this is the x plus ship velocity
Time ship angle.
you need something else. It's something related to angle, but what else? So if I go on a slope at a speed of 10 kilometers per hour, let's say, right? What's the projection, the projected speed on the x-axis and on the y-axis? I'm waiting for the formula. Louder? If it's 45 degrees, yes, root 2. Let's say it's not 45 degrees. Let's say it's a slope of alpha, of an angle alpha. What's yes? Which is it, sine or cosine? So cosine for x, sine for y. Very good. Right, so ship velocity times cosine of ship angle, because this is x, all right? And we're going to have ship position 1 plus ship velocity times sine ship angle, okay? And this happens only if we are advancing, right? So we're going to say if advance okay? So if advance, we adjust the ship position. Otherwise, we don't. Cool? So now we are advancing. Yeah. Okay. Now, what happens if we get out? We kind of lose the ship, right? So it's still there being drawn. Okay, it's still there being drawn, but it doesn't fit into the window, so it's there, we lost it. So one simple solution to not lose it is to have wrapping around. All right, to make it wrap around. So if it's outside of the interval 0 to 600 or 0 to 800, just subtract or add that value. Okay, so we can have a function. I'm going to delete this. Calibrate. All right, calibrate x. And we take a value x if x is less than 0. We do x we return x minus plus we're on x 800. L if x is greater than 800, we return x minus 800. Yes, L if, and actually we don't need to say anything here, we just say return. Okay, and we have a similar function called def calibrate y, or value y. And let's actually not have two functions, right? So I'll show you what happens. Let's do the y, right? If y less than 0, we would say return what? Y plus 600, right? And if y greater than 600, return y minus 600, return y. So if you look at them, they're very similar, right? They only differ in this number, 600 here 800 here. So I could just say here limit, and I could replace 800 by limit and have a single function instead of two, right? And I'm not going to call it calibrate x anymore, but just calibrate. And then in here, when we calculate the ship position, we can say calibrate. And I'm going to do something else to make it more readable. I'm going to say limit first. I'm going to make the first argument to be the limit. So I'm going to say here calibrate. And we're on x, so 800 and this value. And then here also again calibrate 600. And we can close the bracket, right? So now this calibrate will make sure that there's wrapping around. If we go out on the left, we re-enter to the right. Yes? Right, so I go down and you see I come back. I never lose the ship again. Once it starts moving for some reason. Okay, another thing that would be nice would be to replace the image of, as the ship is moving, to replace the image of the ship from non-thrust to thrust. Okay, so I'm going to say this is ship image, no thrust. No, actually this is the ship image. All right, so when I draw here canvas draw image, okay, I'm going to say if advance, right, then I want to draw the ship with thrust. So essentially I'm going to have the same drawing function, right, but my center is not going to be at 45 and 45 anymore. Remember, 45, 45 is here. I want my center to be here. So this is going to be 45 plus 90 on the x-axis, right? So I'm going to do 45 and 135 here. Everything else stays the same. Elif, right? Else, sorry. Okay, so let's see what happens now. Oops, something is not. So we're actually not drawing anything. So for the period of time while the ship is moving, we're not drawing anything. And that's because actually 135 is on the x-axis, right? So I should have 135 and 45. Okay, so now you can see how we have a ship that has thrust. Yeah. Okay. Now we can simplify the code a little bit, right? We have two lines that differ only in one position, right? So instead of having this long line copied twice, I'm going to have a variable called x center equals 135. Otherwise, X center equals 45. And then I'm going to draw and here we write X center. Okay? And again, I did something wrong. Yes. Yes? Okay? So if we're advancing, I'm going to select the center to be here. If we're not advancing, I'm going to put the center here, right? And in this way, I'm going to get the right image. Okay? Let's add missiles. All right? So for the beginning, let's add a single missile. Right? And the missile is going to have, we're not going to have the problem of rotating it, right? But it's going to have the same kind of characteristics. It moves, and it moves at an angle. All right? So we're going to have a missile position. Which I'm going to put it at 0, 0 here, but it's essentially going to be always. We're going to start it at the ship's position, at the ship's tip. All right. So this is where the ship's radius is going to be important, because we want it to go from the tip and not from the center. So we're going to have a ship radius. Let's put it right after the image. So ship radius, and we're going to put it at 30. All right, since it's 45, is 30 a reasonable thing? It was used. So from the end, I have 45. Actually, probably 45 is a better, right? On the OX axis, should be 40. It's probably somewhere in the middle. So 30 is probably too small. Maybe 40 is better. Yeah, let's give it a try. Let's say 40. All right, so we're going to have a missile position, and we're going to have a missile moving. All right. We're going to have an expiry date for the missile. Right? So missile life, and how many drawing cycles do we want it to last? So maybe 10. And I don't know whether it's too much or too little. Right? So missile life will be 10. Missile expiry is going to be 0, right? We're going to have to count how many more drawing cycles do we have till we have to make the missile disappear. All right, so if the missile is moving, then it's showing, otherwise it's not showing. Okay, Now, what do we use? How do we trigger a missile? We trigger it on the space. And the space, I think, I'm going to go and find out. On the space bar, right? And the space bar is space, like this, right? I'm just gonna steal this. So if we press key down, and one press, we don't need to worry about the release. One press will launch the missile. Missile will start at a certain speed, right? So we're going to have elif. I don't have to worry about the release of the key, right? So missile moving becomes true. Right, false should be capitalized. All right. So at the point when missile moving becomes true, all right, also the missile position should become the ship's position, but the tip of the ship, right? So missile position should become ship. So we're going to have ship position 0 plus ship radius times ship radius times cos of ship angle, right? And the same, ship 1 plus ship radius times sine ship angle. All right? So missile position has to become a global variable as well. Now what happens inside draw? So if missile moving, right, we have to draw the missile. Right, canvas dot draw image, and we need the shot. So we have this shot2.png, and we have to go and load it. So I'm going to go and say missile image equals simple GUI dot load image. All right, so we have the image. I have no idea what the size is, but guess what? I can go here, which is a slightly more complete piece of code, and I'm going to find out it's 5.5, right? So it's a very small image, right? The center is at 5.5. It's actually 10.10, and the center is at 5.5. So we want to draw this image. We're going to have a missile image. All right. We're going to put it where? At so what we want to get is 5.5, 10.10, right? We want to get missile position we want the same center, 5, 5, and there's no angle. Right? And if the missile is moving, we also have to make the missile move to the next position. All right? So, missile position, right, will be missile position 0, right? And so missile position is going to become global. And we have a, what we haven't done here is a missile velocity, which I'm going to make it higher. I'm going to say maybe 12, higher than the ship's velocity, right? Missile position plus, and it's the same formula, missile velocity times cos ship angle. But there's another thing now, right? The missile might be moving and then the ship might be rotating, right? But the missile should keep moving in the same direction. So at the point when the missile starts moving, we should capture the angle, right? Missile angle, and I'm going to put it at 0. But whenever we press the space bar, right, we should say here missile angle equals ship angle, right? And then missile angle becomes global. Yes, is this clear? So cos missile angle, right? And missile 1 plus times sine missile angle. All right? What else do we need to do here, right? So we computed the next position, but also the lifespan of the expiry has to increase, right? Or has to decrease. So we have to do missile expiry minus equals 1, right? Because it just went one extra step. And then if we do missile expiry minus equal 1, at this point, we should set missile expiry to be equal to the life, right? So missile expiry goes here. All right, and if missile expiry reached 0, then missile moving becomes false, right? We want to stop it moving. So missile expiry should go here, yes.
We define our missile angle in the definitions.
I hope so, yes.
Even 0.
Okay, what else? Missile expiry should be here. Missile moving should be here as well. Okay, let's see how many errors we have. Yes, here we need a colon. Okay, so it seems to be working. It seems to be too fast. Let's make it a little bit slower. So probably 8 would be good. And then missile life, let's make it longer. Let's make it 25. And make it even longer. Let's make it 50. Missile life. So this is our missile that can, this is our ship that can move around and shoot stuff. Yes? Everybody has this working? Okay, so if you press save, probably this, I'm gonna go and just do this, make this 100. Everybody keep, remember the link. Okay, 100 is good. And probably now can go a little bit faster. So maybe 10. So when you press this, or you press Ctrl S or Command S, you will notice that this link here changes, right? So save and remember this link. Send it to yourself in the email, all right? So that we can continue working on this code next time. Yeah? Okay. Questions? I'm going to send you my link so you can bring your code up to date. Right? So one thing we want to do is have multiple missiles. You see here, as soon as I press again, I destroy the old missile and start a new one, right? Because I can only have one missile at any one time. But what we want is to keep track of multiple missiles, so we want to have a set of missiles. And then we're going to add the asteroids, and we're going to need to do two things, right? Collision between asteroid and missile, collision between asteroid and the ship. All right? I'm not sure whether we're going to get that far, but we're surely going to get collision between asteroids and missile and the explosion, right? And if we get there, it's fine, all right? The last homework will be for you to add something to this game. Okay? Questions?